Screen share?
No, I think we're good.
Yeah, I mean, if you want to do, you know, the way your screen is so that you can present and maybe have the two of us.
Yeah.
I got it. No, I got it. I'll just share here as I always do.
David still says, please ask the host to give you permission to record.
I think I already said it. Let me try again. May
That's
allow
probably me.
remove permission to record. No, you got permission to record.
Okay, it's not working for me.
Hold on.
Or you
Allow-
can record it and send me the recording.
Try again.
Okay, it's still not working. Please ask the, no, it's still not working. Okay, that's
And-
fine.
And how
Just
about
send
you,
me-
Addy? Are you able to record?
Yeah, it's recording for me, so I
All right.
can,
And how are you recording? Are you recording in all three of us or speaker view?
Right, let me change that. It's
Which one do you want to do it? Do yours in speaker view. I'll do
Okay.
mine where it just keeps us all three.
Okay.
And then you could have both recordings and you could put them together if you want.
Mhm. Yeah,
Cool.
that works.
Yeah.
I don't know why it's not letting you record though. That's very, very bizarre because it says my only option is to remove permission to record.
Is it different? Do you have to assign it differently for different people?
No, I mean, I did it specifically to yours on your window.
Okay. It's okay. I'll just take it from you guys. That's fine.
The deep state.
Yeah, there we go.
Right.
And before we start, Tiana, where do you stand on the earth?
This is a hard one. I'm very much on the fence still. I
All
think
right.
I haven't really delved into it as much. I know a little bit of it on the surface, on very surface level.
I know your story. You're on the fence because you've seen a little bit. You don't want to let go of the ball yet, but once you see it, you will let go. Anyone that's on the fence is already a flat earther. They just don't know it yet. They've already fallen in the rabbit hole and there's no bottom. So
I certainly have more questions than I have answers for sure.
well, good. That's what I want. I mean, I want to talk to you. Forget Addy. He's a flat earther. Right? 80.
As you can tell, I'm already there. I'm already level-headed.
All right, brilliant.
Yeah.
So are we already recording?
We are. Start whenever you want.
Okay, so hello everyone. We have the wonderful David Weiss here with us today. And AD and I have actually been trying to get you on our podcast for ages now. I don't know what happened, but I'm so glad you're finally on. And David's been quite, I think it's safe to say, quite a monumental instrument in the progress of the flat earth theory. And I'm just so excited to delve into today's question. So welcome, Dave. How are you?
Thanks for having me. I'm doing great. Love talking to people that are on the fence or don't believe in flat earth yet. And I believe that's where you are.
Definitely. I think I've read a little bit about it in terms of, like in the early earth, as in according to humans, I think they said that it was nothing like a sphere. And in fact, I think they said that very uniquely, they said that the planet was flat with a hemispherical top, I think, like a sort of like a snow globe, right? If that makes sense. And I think it was believed quite popularly that the earth was a flat disk floating, in an ocean with a hemispherical top. And this belief actually in the flat earth was so strong among, a lot of people at that time. I find it really interesting that even after, it was apparently established in the 3rd century that the earth was indeed round, the idea wasn't actually widely accepted until I believe the 15th century. So that's interesting.
My question to you is, where are you getting your information from? From the people that were in control. You're getting your information from literally the people.
This proves flat earth a little bit, doesn't it? Like in the sense that it took, why did it take such a long time for them to believe that the earth was round? Because
I think you have your data. You're right, but it's worse. I think that they convinced people the earth was round in the mid 1900s.
Oh,
not that long ago. Mid 1900s, they were teaching flat earth everywhere, but then they came up with, Aristophanes, the story of the sticks and shadows, which doesn't, if you want to look into that, you'll see that it doesn't prove anything. If anything, it proves the earth is flat. But they brainwash everybody into believing, oh, the Greeks figured it out 2,000 years ago with an experiment that doesn't work. And they just make up all of these stories when in fact we don't know anything before, early 1800s.
I have a theory that the 2 world wars the First and Second World War was their perfect opportunity to delete as much history as possible,
Absolutely.
and create the history that they wanted for us to live with. You can imagine the trauma that all the Western countries went through and after the 40s to then shape the 50s and 60s, and then all the textbooks that came out, like you say, from the is it the Rockefellers had all the textbooks. So this is what happened in the 1800s.
Right. So they have
everything.
They have everybody in the indoctrination system, in the public school system, and they purposely underfund them. And then the Rockefellers will send them books at a fraction of the actual cost to make the book. Okay, they're not making money on the books, at a fraction of the cost. That way, no competing book company, let's say you and I get together and say, hey, we're going to write a better science book. The schools can't afford it. And they're going to get the curriculum from the approved curriculum. And it's just a giant game. It's a giant scheme, if you will, to indoctrinate people into these world beliefs. Like one of the first sheets a kid brings home from school is where are the planets? You know, the planets, the orbits, the sun, the moon. I mean, you might even remember that sheet, bringing it home. It's the same sheet they're giving kids today that I got. Okay.
I have a young daughter, and the brainwashing on every single cartoon, the dinosaurs, the planets, the moon, everything. It's in everything, and it's it's just frying my brain.
Dinosaurs, planets, but then they also throw a little truth in there, like the new Pinocchio, the 2022 Pinocchio with Tom Hanks. Let's not even get into what Pinocchio represents and Tom Hanks' is role in it. But he's Geppetto, and Pinocchio goes outside for the first time and goes, "What's that bright thing in the sky?" He goes, "Oh, that's the sun. It circles the earth every day." Boom, right? Little flat Earth truth, right in a new movie.
I didn't know that.
Yeah.
Yeah, I won't watch Tom Hanks or any of those films
I know.
anymore.
I just saw that clip, so it's very interesting.
Yeah.
So take this anywhere you want, but the question when you're ready is, what makes you think the Earth is a globe besides somebody in a bow tie told you?
True. I can't really think of why I arrived to this.
Right. Well, you get 3 Bitcoins.
three Bitcoins for one proof.
Is that actually real, Dave? You're actually offering a prize of 3 Bitcoin.
100% real. You know why? Because the Earth is not a globe. I mean, it's plain and simple. Now, what is the flat Earth exactly? God, we have a lot of questions. We know we have questions. We know we don't know a lot of things. But globers think they know everything. They think, oh, well, the Earth goes around the sun, the moon goes around here. We're traveling at all these different speeds, all these different, motions, but we don't feel it. We're spinning at 1,000 miles an hour in a curved trajectory, not in a straight line, in a curve. So that rim speed and the drop is beyond anything I think a human could even withstand. We're orbiting at 66,000 miles an hour. We're chasing the sun at about 500,000 miles per hour. Okay. But we don't feel any of this. Now they go, well, you're already in motion. Well, all of those motions are curved motions, right? They're not straight lines. But when you're flying in an airplane or on a bus or on a car or on a bicycle, going in a straight line on a perfectly smooth road, you can feel those motions. 50 miles an hour in a car, 500 miles an hour in an airplane. You could feel that you're moving forward. Right. But the 1,000, the 66,000, the 500,000 miles an hour in all these different directions, you can't.
66,000.
66,600.
600. Yeah.
Right. Right. So, but you can't feel any of them. Right. So this is what you have to believe if you believe in the globe. And the sun, like where the sun is today, if you had the whole universe, it's 4.5 billion miles somewhere else next year on the same day. And then it's 4.5 billion miles farther the next year. Okay. But somehow when you look up, all the stars are the same. All the stars are the same on the same day at the same time every year. Go out. I tell people, take picture of the sky from a certain point in your yard and then put a note in your calendar to do the same thing on the same night, the following year and the following year and the following year. And all of the stars will be the same. Does that make any sense to you?
That's interesting. Wow.
Can I just say, I took your advice on that. So June 2021. Yeah, on the recent chat I just did. You don't know this, Tiana, but I went on a chat 2 nights ago, ex-Jehovah's Witnesses. Yeah, I discussed this. So basically, I really started looking into Flat Earth 2021, June 21, as I was moving house. And as you say in your interviews, you know, look up at the stars, check it a year later, they're exactly there. So I did that above my garage, the Big Dipper, checked it, you know, roughly it was around about the 25th of June we moved. There you go, 25th of June 2022, exactly the same place. So,
Oh, wow.
so
Yeah.
like, and I have been paying attention to the stars, which I never did before. The way the moon moves across the sky, and the way the sun moves, and you can see once you know the sun's path, you can see it coming towards you to the summer, and then going away. And it's going to do exactly the same thing as it did last year. Since I've been in the house, I've got points of reference now that I've been paying attention to it. So that, you know, this is how farmers in the olden days used to be able to, you know, judge when they needed to sow the seeds and all of this, because of the sun's path. You know.
So where does the sun go if the earth is flat, and how does it set? How does it rise?
Great question. Okay, let me just show you one thing in reference to this. I show it on all my shows. This is the hypersonic rocket sled track. Okay, it's going to go by at Mach 8.6. Watch again. You can't even fathom this. And if you Google it, if you Google hypersonic sled track, you'll get this video and you'll hear it. It's shocking to your body how fast it's going. What? Ready? Mach 8.6. Can't even see it. You have to believe that you are traveling 10 times faster than that, orbiting the sun. Okay, and you're chasing the sun 100 times faster than that. 100 times. You can't fathom twice as fast. As a matter of fact, you can't even fathom this speed. You can't fathom it.
Yeah.
Okay, but then we go outside, we see stuff like this. What does this tell you? What does your God-given common sense tell you? We're not moving.
I've been fortunate enough to have seen places like this in New Zealand. There's a place near Milford Sound called Mirror Lake, which I've got many photos of. I used to live in Milford Sound, and yeah, the lake, every time I went past it, was always calm and like a mirror lake. So like,
Right.
you know,
Well,
it wasn't just like a one-off. It's called
what's
Mirror Lake.
holding that water from flowing away, right? Not what's holding it down. What's holding it from
gravity?
flowing away? No, not what's holding it down, because everyone, gravity is your superhero. It's the only thing that holds the ball together. But we're going to take that apart today.
Okay.
Water needs lateral pressure. If you had a bowl of water and you remove the sides of the bowl, water's gone. It's going to seek its next base level. It's going to level out, right? So the land that surrounds this lake is the shoreline of the lake, right? And it's holding the water in. It's giving it the lateral pressure. And the land's not moving. Get a dinner plate, fill it to the brim with water, and then try to walk across the room. Even put it down on like a roller coaster or something and roll it across a smooth counter. That water is going to be jiggling. You know, try to take a turn. Do it in a car going, set speed, and then have that car speed up, slow down the tiniest bit, or take the slightest turn. The water is going to slosh, right? It's not going to look like this. So, yeah. So if you expand that idea out to the whole world, our world pond, this is, whoops, there we go. This is our world pond. This is the shoreline of our pond. It's higher than the water. You know, they do tell us some truth. Antarctica is the highest land on Earth. Makes sense. Antarctica is the shoreline that holds in our world pond.
Is it true that we are still allowed to visit certain parts of Antarctica, or?
You see this little peninsula right here?
Right.
Can you see the very, 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 very tip of it that's thinner than that pink line? No, you can't even see it. That's where you're allowed to go. Okay? And by the way, this little peninsula right here is bigger than many countries. It's gigantic. You got there, you can't see anywhere else. This is huge.
Right.
This is massive. This is a country, right? And you're allowed to go on a ship here. It costs you, they price it out for, you know, where it's out of most people's price range. For like 3 days, it's like a minimum of 10 grand, I think. And there's 100 different companies, all run by the same guy. He has 100 shell companies acting like they're different companies. And when you get there, they barely let you off the boat. But even if they did, He said, you know what? We'll give you 10 hours to go explore. How far are you going to be able to go on this icy, treacherous shelf here? You're not going to go anywhere.
Yeah, that's
And you know, this is, you know, if you, it's hard to see America here. This is like, this could be 1,000 miles, right? Before you even get to the real shoreline.
It's probably bigger than the UK.
You're not going anywhere. Okay. You're not going anywhere. So what's out here? We get into that. But you asked about sunsets. Where does the sun go?
Just
Right?
just a quick one on that, Dave, before you go. Like obviously
go.
we're in the UK. Where does the Crown have strategic islands? There's a meme that you show where it shows all the British flags that guard all the
Yeah.
all the shorelines of Antarctica. It's like Pitcairn
So
Islands.
it's called the Antarctic Treaty. And where is it? Here we go.
That's it.
These are where all of the islands, and they all have crown-controlled military bases. So anybody that goes out here, now they have buoy networks, you know, communicating with each other, basically a grid that you can't go in without being seen, right? Because satellites is a whole nother story. And so you cross that line, they're going to stop you. But here's the thing. Unless you are funded with millions and millions and millions of dollars, and you have incredibly talented explorers and mountain climbers, you're not going anywhere. You're not going to get anywhere, even if they didn't stop you. Okay. I wonder how far out Antarctica goes. Now, this is not a disc. This is just the end of the image. Okay. We're just showing you, we don't know what's beyond the shoreline of Antarctica. Okay. With me?
Yep. So it's possible that it is truly the edge of the earth.
Well, we don't know. Maybe there's a dome that terminates.
Right. Okay.
Maybe it goes on and on and on. We don't know. And we're not afraid to admit we don't know.
And the other side of the argument is that there's infinite space vacuum. Which is
But how do they verify this without actually having gone there, without any evidence? What is their argument for this? For round earthers?
I mean, globe earthers.
Globe earthers, yeah.
They have none. They have none. You know, they tell you Antarctica is a continent at the bottom of the ball, bottom of a ball, right? They show us Antarctica like this, right? But there's no aerial photography of Antarctica like there is everywhere else in the world, except again the very North Pole. But you can just see what's at the shoreline, and basically they took that flat Earth map and they wrapped it around. And they said, oh, that's Antarctica. So we don't know what's in here because you know what? This isn't real. This is the outer edge of our world, right?
And it's the only country that has their country on the flag as the flag. It's the only flag that has a country as its logo on the flag.
That is interesting.
Which is weird.
Yeah. I'm trying to find I have an animation. I have to figure out where that is. Right. All right. So where does the sun go? Where does the sun go? So it's all about perspective. And there's three layers. We have the earth, terra firma, the oceans, the earth. And we have the atmospheric layer. And we have the celestial layer, all right? You with me?
Yep.
And everything, as you look into the distance, just goes together. Everything comes together. The land layer meets with the atmospheric layer, and then the top layer, the sky, meets with the atmosphere. It all just comes together in perspective, all right? So I'm jumping all over the place here. There it is. So here is an example of just some street lights meeting. They just merge with the road. Here's the sun. The sun is just merging with the horizon. So this is showing you that the sun is just going away. All right. You with me?
Yep.
So let's look at a side view here. So here's our atmospheric layer. Here's our celestial layer, all the lights in the sky above the atmospheric layer. And here's our terrestrial layer. So we're looking at a side view of this. Nobody ever sees the world in a side view. This is an impossible view. You don't see the side of your face. You see forward, you see to the left, you see to the right, and everything is converging. You never see this, but this is a side view. We're looking at what it would look like if you could see a side view. So let's go jump forward here. So this is how you see everything. Everything merges together, okay? Everything converges together. So let's go a little farther. And as the sun moves away, it's going behind these clouds. Jump back a second. When you're looking up from here, you can see up, you can see the sun. You can see up, you can see the sun, right? But as it gets farther and farther together, you can't see through. It becomes opaque, okay? It becomes an opaque line. So here it is. The sun just goes beyond these clouds. Now, your angle of view, this black line here, is getting blocked by these clouds. It's solid cloud, atmosphere. It just becomes solid. So you can't see the sun anymore because it's beyond it. You understand?
So it doesn't really set. It just goes behind.
It goes away. It goes away. Now I'm going to show you some real things. So the sun goes behind it, but on the ground, we can zoom in on a boat, okay? Or a building, because we can increase the angular size of where the sky meets the land. But we can't increase the angular size beyond the atmospheric dome of opacity, I call it, or a deck of opacity, because we're underneath it. We can't see through it. We can't see through it. It'll become a little clearer in a second. Okay. So let me show you my, where is it? Oh, in the wrong one, sunsets. So this is a little experiment that I did in my kitchen. I know you're very familiar with this, but it's a good one. I am losing all my stuff here. Everything got moved. Here it is. Sorry about that. All right. So this is not it. Wait. Why does this say? Oh, I have something else clicked off. Sorry about that. Here we go. So here's my kitchen counter. It's my flat earth kitchen. I got this line here. It's the path of the sun. And I'm viewing it from a celestial vantage point. I'm up high. And so this could be mountains, a city skyline, or the cloud deck. I'm above it. It's opaque. The sun never goes below it. Now I got a camera on the counter on the other side. And now I'm looking up at this. Look at this line. Does it look like it's level? It is. I just showed you it's level. Does it look like it's going below this opaque barrier, which is now at eye level? Okay.
Oh, wow.
It went below it, but it's not. Now look, I zoomed in. Look at that line. If I showed you that first and said, is that level or is it going down? You'd say it's going down.
Yeah, I would.
And this is just going beyond it. So here's my simulated sunset versus a real sunset. And look what it's going behind. This is the atmospheric deck of opacity. And if I zoomed out on this picture, all of that would just merge into a solid line.
So this sounds like a stupid question, but where are the people, as in, what about the people who can see it from, well, basically when it sets, from my perspective, what are other people on the other side of the earth seeing?
Oh, they're seeing it rise as it comes towards them.
Okay.
Okay. So,
I've seen, sorry.
Go ahead.
I've seen many sunsets at Cafe Del Mar in Ibiza exactly like that. So many.
It's just going beyond where everything converges together, and because it's celestial.
And it never made any sense to me, because I was like, well, isn't the sun supposed to go and touch the water, like go below and touch the water? And it never did. It would always go exactly like that behind some clouds. And I was like, oh, that's a disappointing sunset.
So here you are.
Now I know.
You're looking up at this cloud, and it's 5,000 or 10,000 feet above you. And here's a straight line. Let's pretend we pulled a string from your eye to the cloud. It's shooting straight up in the sky. And now these clouds are all at the same level, but they go down due to perspective. So we zoom forward, and we have one cloud way over here. Now, in your mind, you know that this cloud is still at the same height. But if I drew a line to that cloud, from your point of view, this line is just going parallel across the water to this cloud, which appears to be close to your eye level, right? So we're drawing a physical string. And from your point of view, that string is 5 feet above the water, okay? 6 feet above the water, whatever it is. But what would I see if I was standing underneath this cloud? Okay. If I was standing underneath this cloud and could see the string, I would see a string coming from 5 or 10,000 feet in the sky, sloping down to you. But you see a string that's level across the ground.
That's true. Yeah.
Okay. So now let's just go a little farther. The sun goes straight across the sky. Now, this again, a side view, which no one ever sees. Here I am underneath the cloud. Here you are. And this is the actual line hitting that cloud, which appears to be on the horizon from your point of view. And as the sun moves beyond it, you can't see the sun once it passes this line because it gets eclipsed. Right? And so if we put it from your point of view, we see the sun go down, 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 and then it looks like it's going behind a horizon.
It does. That is so interesting.
Isn't it?
What they don't teach us at school.
They don't teach you that in school. So if your mind wasn't so blown right now, you'd go, but wait a minute, if the sun was going away, it would get smaller.
That's
right.
true.
Yes.
Yeah.
Yes. So let's talk about that. Why is that doing that? Hold on. All right. As things go away from you, they get smaller. But when we're dealing with the atmospheric deck, which has moisture in it, it becomes like a magnifying glass. Okay. I'm going to show you a couple examples of that. So as the sun is going away, getting a little bit smaller, it's also being magnified the farther away it goes. So it's kind of like keeping it, it's balancing it. Okay. And the issue is, but the other thing is, so what this is showing you right here is we got a train car where this is a terrestrial object at my eye level. It goes away, it gets smaller. Absolutely. 100%. We've all seen it a million times. Okay. It's not actually getting smaller, but it's getting smaller, which is implying to us that it's moving away into the distance. We read all these visual lines, so these visual clues. So here are parallel lines on a wall, but look how these lines are almost going straight down. They're parallel, but that's how we see them. So again, here's a side view. Here I am looking up at the sun above me. And as it goes away, which is going to go down, right here it goes. It's going to look like it's going down, but this is what's going on. Side view again. Okay. Now, because the sun is already up in the sky away from you, it's already smaller.
Yeah.
So the size that you see it when it's over your head, it's already smaller. So when it goes away, it doesn't get very much smaller. It does a little bit, but then you have atmospheric magnification. You have all sorts of stuff, and glare, and it's so difficult to accurately measure it. So here's some train cars, higher, higher, and higher. The train car is already small, and as the train car goes away, it doesn't get much smaller. Okay. Now, I believe I believe that the sun that we see at sunrise is far less than 200 miles away. That's me, Flat Earth Dave, talking. Not everyone else believes this, but it's not a physical object. We see it in what I call our personal atmospheric dome. And I could show you many experiments that will maybe make you see it the same way. All right. And that means if it's 200 miles that way, it means it's going to set 200 miles that way. That means it's only traveling 400 miles during the day over 12 hours. That's not that far. Okay. So here we go. We have a wiffle ball, and 6 feet away, we have another wiffle ball. Same size, but it's tiny because of perspective. But what if we move this to a celestial point of view? So pretend this is upside down and we're raising it up to the ceiling, but in reality, I'm just raising the camera. So I'm going to lift the camera up, getting no closer to this ball. I'm just going to move it 6 feet above this ball. All right. So as we move up, here it goes, it's coming. So as I get higher, I'm not getting any closer to this ball. Look, they're both becoming the same size. Right? I'm still directly above this ball. Right? And then
Mhm.
you add the atmospheric lensing in there. Pretty interesting, right?
That is interesting. So I've always wondered, this is probably from a question from my lack of understanding in astronomy, but why is space dark if the sun is so powerful and if it is really in space?
Well, the argument is there's nothing for it to reflect off of.
That's right, it's a vacuum. Yeah.
Well,
that's
well, that's
yeah.
another problem. Light propagating through a vacuum. How come on all of the space pictures from the moon and everything, there's no stars, right? And they go, well, it's because the Earth is so bright, it can't see the stars. We've taken cameras, stood underneath a bright street light at night and filmed stars beyond the street light. I think the contrast of that is far harder for our crappy little camera to film. But here's a sunset in Afghanistan on a cool, dry, no humidity, and the sun is not going down. It's getting smaller and smaller. Now you could argue that it's just because it's getting farther, you're seeing less glare, but it's not going down.
Yeah, that didn't go down.
It's going away. Okay.
Mm.
Right. Here's another one. This is in Bulgaria. Right now, is the sun just whatever this thing is, this apparent light? Is that just moving away and setting due to perspective, which you just got a full college level course on? Or is the cameraman falling over backwards faster than the speed of sound, making the sun appear to go below the physical curve of a ball? What I mean by that? If
Wow.
I'm the cameraman here
Hmm.
and the sun is over here, to make it go down, I have to be falling backwards faster than the speed of sound. Faster than the speed of sound.
That's just one of the directions.
That's just to make the sun set.
Yeah, I know,
okay.
yeah.
That's
I know.
just to make the sun set, right? When in reality, lakes, nature tells us, nature doesn't lie. We're not moving. We're not moving at all.
Then what role does gravity play in all of this? Because the people that I speak to who believe in flat Earth deny that gravity exists completely.
Yeah. So let me just show you one more, and then we'll switch to gravity.
Okay.
And this one might make your head explode. So cool, dry day, looking west over land, no humidity, freezing, below freezing. So there's no humidity, super clear day. The sun was way up here, and in 5 minutes time, it went down, 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 down. And it should just keep on going if we were spinning at an even pace, but it didn't. It went down, 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 and stopped. I'm filming this from a drone at a pretty high altitude. The sun sat here. This is super sped up. And it didn't go down below here. It just faded away.
What?
Because its light isn't strong enough to push through all of the atmosphere. Okay. Now, my friends were at the beach over here. They saw the sunset from the bottom up, just like in all the examples I just showed you 10 minutes earlier.
Wow.
I've done this as well with
Yeah.
my drone and the time lapse, the hyperlapse feature, and I've just seen the sun just going smaller, and
Right.
just fading
Here's a
out.
quick example of this candle is not being pulled down below the table. It's not being pulled down. It's just being pulled away. And we have a lens here, which is acting like the atmosphere. Okay, I'll show you. It'll show you what it's doing in a split second. So here is, where is it? Speed forward a little bit. So here's the setup. We got a little dolly here with a camera on it. We got the iPhone filming. And as it just goes away, it looks like it's dropping down.
Oh, yeah. I can see that.
There's nothing blocking it.
Oh, my God. That is crazy.
Yeah, it's good stuff. And here's the thing. Have you ever thought of any of this? Has anyone ever brought this up? Has anyone ever tried to teach you this? Why? Right? Here's another. This is one that our fellow fallen flat earther, Rob Skiba, the sun is dropping. It's setting. He's just pulling it away. Filming it here. Here's the atmosphere. He's just pulling it away. And the sun sets. And You ask what people on the other side would see, they would see it rising, but here it comes rising, put a landscape in front of it. Exactly what we see.
Hmm. Wow.
There you go.
That's interesting. Okay.
So
That makes a lot of
gravity.
sense.
Gravity.
Can I just say one word about gravity? And this is just my theory on it.
No.
Gravity is trying to pull you 6 feet under.
Great.
I like it. I like it.
That's a good one,
That's
AD.
it's just trying another 6, trying to pull you 6 feet under. Come to the
Mm.
gravity.
Maybe later ask about, you're taught how did the universe created? What was the beginning of the universe?
The Big Bang, apparently. Well,
The Big Bang. So nothing exploded, created everything, then lightning struck, created a one-cell organism that divided into cells, turned into a tadpole, grew legs, climbed out of the water, turned into a monkey, turned into a human, right? Okay.
Yeah.
So ask me about that later. Let's talk about gravity. I have an amazing analogy.
But also,
you're not
Big
ready for
Bang theory doesn't make sense in my head, because you can't create energy. How did that happen in the first place?
Well, a priest made it up, so you can make up the reason that it happened also. So it's not even a scientist, a priest made it up. All right. So I got my ball here and I drop it. Why did it fall? Well,
Not gravity.
You're gonna say gravity. Well, it's more dense than the air. If I had a helium balloon and I let it go, it's gonna go up. Well,
Mhm.
where's gravity now? Okay.
Mhm.
It's more dense than the air. And so buoyancy and density, right? Buoyancy is holding the ship up. It's holding this blimp above the ship. It's holding this submarine below the water. Okay.
Right.
Buoyancy and density sort everything else out. Now, there's many flat earthers that argue that there is no force. There is nothing. Down is down because of density. I'm not one of them. I believe, if I was holding this ball and I snapped my fingers and the entire world disappeared, I'm now in the middle of a void. There's no matter anywhere else except me and this ball, and I let it go. Why would it go this way and not that way or that way or that way, right? What's determining down?
It's just
with
the
me?
mass of the ball, isn't it?
Well, the mass of the ball, but what if there was no Earth? Why would it go in that direction?
Why?
So there has to be some sort of reason buoyancy and density sorts up and down and not left and right and forward and back.
Right.
Okay. Up and down are the only definite directions, because point down right now. Go ahead. Point down. We're pointing the same direction. Point up. Okay. Point left. Now we're pointing different directions, but we're both pointing left, right? Point forward. Now we're pointing opposite directions.
Mm-hmm.
Well, I mean, it depends on what you're looking at. It depends on what you're looking at. So, if we are standing back to back, forward is in opposite directions. Backwards is in opposite directions. Left is in opposite directions, right? So up and down are the same for everybody everywhere. Up for people in Australia is this way. Up for me here is this way. Up for you. Up is up. Down is down.
Yeah, it's not relative to where you are, right?
And Australia exists. I've lived there. So
I've been there. That's another thing. Flat earthers, we don't know a lot of things. We know a lot of things. One thing that we all agree on is that we understand that the ball, the rock surrounded by water, the lumpy rock surrounded by smooth water, surrounded by high pressure air, without a container adjacent to a void, is retarded. Okay. Am I allowed to say that on your stream?
Yeah, absolutely.
It's just, it's of a brain that has not begun to function if you can actually believe that is something real. And we're told that Newton, the apple fell. What if a kid let go of a helium balloon at the same time? Would he have come up with gravity?
Mm-mm.
I don't think so. If the story of Newton's even true, which I don't think it is.
It's such a silly story. Gosh.
They're all Freemasons, aren't they?
It's all, if they were even real, okay? All right, maybe they were real Freemasons and the stories are made up about them. Who knows? Or they're just playing the part. Again, they're all, it's all a big scam. So the sun and the moon are the only true forces in this world are electricity and magnetism, and they go together, right? You ever drop a neodymium magnet through a copper tube, a copper pipe, or through a roll of tinfoil?
Mm-hmm.
Anyone that has a neodymium magnet, get a full roll of tinfoil, take it out of the box and drop the magnet through. It doesn't fall at regular speed. It slows down like incredibly slow through midair, right? And that's because it's generating a current. It's the whole thing. It's the only true forces here. Try that. It'll blow you away. The sun and the moon are the anode and cathode of the Earth battery system. The salt water carries the current. The land is the salt bridge, and that creates a battery. So the Earth has a neutral or negative charge, and the sky is positively charged. The dome, the air, the sky, it has a positive charge, okay? So anything that's lifted up off the floor is now surrounded with that positive charge. And the floor isn't moving, as we showed you with the lakes and everything else. It's not moving. So it says, hey, down is this way. It's a weak force. It's a weak electrostatic force, which is, the number is ridiculous. 10 to the 20th power stronger than gravity. This is what science, the science gravity lovers say, that the electrostatic force is 10 to the 20th power. You know how big that number is? And I'm going to answer for you. You don't, because the number is so ridiculous you can't fathom it. Okay, so a trillion has 12 zeros. One more zero adds. It goes even. You have to add 10 more zeros to get to 8 more zeros. Sorry.
Yeah, it really is unfathomable.
The numbers are ridiculous, right? You know how long a trillion seconds is, right? Do you know how long a trillion seconds is? Take a guess and you can win. You can win it. You blew it. I was going to offer her a Bitcoin.
Sorry.
It's 31,000 years. Wow. 1 trillion, just let it sink in. A trillion seconds is 31,000 years.
Oh my God.
Well, that's 12 zeros. Okay. And they're telling us
give her
that
half a Bitcoin.
The electrostatic, I'll give it to her in 1 trillion seconds. Okay. Okay. So the electrostatic force is so much stronger that you can't even fathom it. And that's what they say. I think they're lying. I don't think it's that much stronger, because I don't think we'd be able to stand up if it, but again, gravity doesn't exist. So they're comparing it to nothing. So you multiply something times 0, it's 0. So what can we do to show how this works? So this is where is it? Okay, so this the one I'm looking for? All right, so here we go. We got some helium balloons. We tied them to this. This is just a metal button here. And we tied it to the end of we hooked it to this wire, which is hooked up to a Van de Graaff generator, which can add a charge to something. Okay, so we're going to add a positive charge to this. We're just adding a positive charge. And it got heavier. Now, are we increasing the weight?
No.
Are we increasing gravity, or are we changing the electrical charge?
Oh my God, you're changing the electrical charge.
And now it's being pulled down. Okay. And so let's do the opposite. We add a negative charge, and it's still being charged, and it goes up. Are we defying gravity, or are we defying the electrostatic charge of the Earth?
Right.
Okay. Gravity's made up.
Wow.
Gravity's made up. All right. So here is MIT created this. It's called the silent drone. No moving parts, makes 0 noise. It's just changing the electrostatic charge. And it flies. Are they defying gravity?
I want one.
I want one too. Are you kidding me? I want one, but it needs a Tesla coil that can pull energy out of the ether so you never have to land it. Okay.
Interesting.
Yeah. It's all
But
interesting.
then what about the tides of the ocean? Doesn't the interaction between Earth and the moon prove that gravity does exist in some way?
Oh, you got me there. Earth is a globe. I'm sorry. So let me first give you the official story on gravity. And if you actually look, I'm sorry, on the tides. If you actually look at the actual tides and whatnot, they don't line up with the moon. Now they do have some correlation to the moon, but why is there a higher tide when there's a full moon than when there is a new moon? Because in the heliocentric system, the moon is still there. It's just not lit up, right? When there's a new moon, it's still there. Matter of fact, it's right near the sun. So the sun and the moon should be pulling on the gravity. It should be massive tides.
Right. Okay.
So here's the Earth, this inner circle here, and here's a high tide. This blue area here is a high tide. Here's a low tide. Here's a high tide, and here's a low tide. Okay. Okay. Try not to laugh. Right. If you don't laugh, I'll give you 3 Bitcoins in 1 trillion seconds from now. Okay. So my head is the moon. Okay. No, I'm going to give you a moon. Here's a moon. And it says that the moon's gravity is pulling the water away from the Earth, causing a high tide. So when asked Neil deGrasse Tyson, the high priest of scientism, why is there a high tide on the other side of the Earth over here when the moon is pulling? He goes, oh, that's very interesting. It's because the moon is pulling the water away from the Earth. And at the same time, it's pulling the Earth away from the water on the other side.
That makes no sense.
Oh, you blew your Bitcoins. You could have had 3 Bitcoins in 1 trillion seconds from now.
He actually said that.
He actually said that. Okay. And then the Earth, ready? So you got these 2 bulges of water and the Earth spins through the bulge.
Interesting. Gosh.
Interesting. It's so stupid. It's hard to even fathom that somebody could say that. Okay. So there's all of these areas where the world has these no tide zones. There's like no tides, high tides, low tides. None of it makes any sense, except if you lay the electromagnetic field lines over the Earth. They kind of line up with this in a way. It needs to be looked at a little deeper, but there is a heavy correlation in between that, right? And think about this: gravity, right? The little moon, 250,000 miles away, can pull the friggin' oceans away from the Earth. It can pull the Earth away from the ocean, but the stronger gravity of the Earth can't pull the water out of the clouds when it's not raining. There's billions of tons of water in these clouds floating.
That is true. That
And
is
gravity
very inconsistent logic. Yeah.
Yeah.
So how would you explain the eclipses or just the phases of the moon? Like, how are lunar eclipses even possible if, both the sun and the moon are the only things that are orbiting above us?
All right. So what causes a lunar eclipse? So a lunar eclipse is when the sun casts the Earth's shadow onto the moon. That's what they tell us. So you got the sun. Where am I? How come you can't see? Oh, you can't see it because it's green. All right. So you got the sun. Here. It casts a shadow onto the moon. So as the moon comes in between the sun, it casts a shadow on the moon. As the Earth comes between the sun and the moon, or sun and the moon, it casts a shadow on the moon. That's what we're taught.
And it's a curved shadow, right?
It's a curved shadow. But do you know that when you I can't show you here, when you use a sphere to cast a shadow on another sphere, as it's coming on, it comes on as an ellipse, it spreads out, and then it leaves as an ellipse. Okay. So let's there's actually an eclipse. I think it's coming up this year. I forget when it is. It's called the impossible eclipse. It's called the Seleninian eclipse. And it's where the observer, who always considers themselves on the top of the Earth, can see the sun and the moon both above the horizon. What does that mean? If the sun and the moon are both above the viewer's horizon, that means that the Earth is not in line with them yet, right? Because the Earth is below that direct line. Well, we had one recently, and the eclipse came in from the top.
Oh.
If the Earth was coming up, right? If the Earth was coming up to eclipse, the shadow would come in from the bottom.
Yeah.
Right? But it came in from the top.
So what does that mean?
So what it means is it's not the Earth. Am I making any claims as to what it is? No. Right? Now there's the Vedics and all these other ancient cultures talked about Rahu and Ketu and these dark bodies in the sky.
The black
And
sun.
yeah, all sorts of
Oh, yeah, the black sun.
different things. So I have hold on a second. Where is it? I think I have a new video. That's not it. Well, let me show you this first. So this is an eclipse that I filmed. This right here is an eclipse I filmed. It was a little hazy outside, so it was really easy to film it. And we don't see the moon. We just see something eclipsing it. Okay, you with me?
Mm-hmm.
So this is an actual eclipse that was being filmed also. And the eclipse is literally this, whatever this is how much the sun is eclipsed, but you can't see it because it's so bright. It's just blowing out the lens, but it's like 85% eclipse right here. But we see these two little mini eclipses going on. We're like, what are those? Well, this one is clearly a lens flare because we're moving the camera around, but this one's not bouncing around. This one is locked into position with the sun. Not a lens flare. What is it? I said, what if that's the source of the sun? What do I mean by that? That the sun is like a rear projector. You ever watch on a movie screen with a hanging sheet? You got your picture on the sheet, but if you look through the sheet, you can see the source.
Yeah.
Okay. So no one ever sees the moon eclipse the sun. They never see it approach. They never see it eclipse. And they never see it exit. But here we got the source, we got the projector. This bottle cap is the eclipse, and you don't see the bottle cap. You only see the apparent sun being beamed into your sky dome, into your apparent sky. Well, here it is again with a thinner sky, and I got the eclipse coming in. Here's the eclipse, and here's the source. There's the source behind, and this is the eclipse. And this is why you never see the sun. Look, it looks the same. It looks the same. So am I making a positive claim here? No. I'm saying that this is a great explanation. Could there be another one? Yes. Is the heliocentric one possible? No. So there's things that we know that can't work. The Selenian eclipse doesn't work. This does work. Can demonstrate it in a model and filmed it. Why can we see this and not see it all the time? Well, the sun is 85%, 90% dimmer right here, and we're able to see it from the right angle under the right conditions. But when the sun is up in the sky, you can't see it. It's so bright, you can't see the projector behind it. Okay?
Flat earthers say that light bends by large amounts and its speed also varies by large amounts, right? But to give us this illusion of a round earth. But what do you think causes that effect on the light?
Well, when light goes through a different medium, when you're looking at light through different medium, through water, through moist air, it will refract. It will bend. But they use that refract. Oh, well, since it refracts that, every time you see something that's too far to see, it's due to refraction. Here's one for you. Without getting too far off topic. So here's a viewing spot in Illusion, France. Out here is Mount Canigou, but it's 185 miles away. At 185 miles, using the Earth curve calculator, which is 100% accurate, from this altitude, the very top of Mount Canigou should be a half a mile or more below the horizon. You with me?
Mm-hmm.
It should be below the horizon. Can't see it. Well, you can't see it. So here's the question: can you see me right now? If I turned off all the lights in my room, could you see me? You're seeing the light that's bouncing off of me. Well, the light that's bouncing off of Mount Canigou at 185 miles away doesn't have the strength to push through all of that atmosphere, and it fades out, just like I show you the sun faded out in my sun fade out video. Okay, but the sun is brighter than the light reflecting off of Mount Canigou. The light over here is brighter than the light that's bouncing off of me, right? So twice a year, when the sun travels in between the tropics, twice a year, the sun will line up with the viewing spot and Mount Canigou. And when it does, all of a sudden you can see Mount Canigou. And the very top here should be over half a mile below the curve. But it's here. It's right there. It's not a mirage. It's blocking the friggin' sun. It's right where it's supposed to be, right? But the globalists will say, oh, no. That mountain is over the curve. The sun is already set, but it's refracting up and magically stopping at eye level or about eye level. Okay.
Every year.
Smiling. every all the time. Yeah. every year, all the time. Okay. It's a mirage. It's gravity. It's all they got. They got nothing, right? The globalists, the anti-flat earthers, the ones that are deceptively, purposely lying, they even admit that you can't see a physical horizon on a ball. They say you can't see a physical horizon. Here goes my hand. It's a boat, and it disappears behind a physical horizon. Zooming in, can't see. Zooming in, it's still there. Physical horizon, it's hidden, right? But on our world, the Earth is an optical horizon, right? So in the distance, everything comes together. But if I zoomed in to where the sky meets the ground, I can increase that angular size and I could see it again, right? So there's nothing out here. So we have the sky meeting the ground. And I'm zooming in. I'm making the optical size bigger and bigger and bigger as I zoom in. And look, there's a boat. Did I zoom over a ball?
Wait, this is so confusing. So what I mean, the biggest question they do ask usually is that the way to disprove, I guess, the flat earth theory is that why does the bottom of the boat always disappear first if there is no curved horizon? I don't understand this yet.
But I've never heard that question before.
It's the biggest question that they ask, isn't
Oh,
it?
wait a minute. I'm just about to explain that. Okay. So see this little wave right here? If I move that wave to right next to the boat, how much smaller would that wave look? Be a lot smaller because it's farther away, right? Right. So here we're going to bring the boat back. Boat's big right here, right? As I move away, the boat's getting smaller and smaller, and these waves in the foreground here are hiding the boat.
Oh yeah, that's true.
It's called the
sounds so
wave
simple.
front edge. It's called the wave front edge. And now also the angular size of the boat has become too small to see. Okay. It's become too small to see. Now, as I zoom in, it's getting bigger and bigger. We're zooming in more and more. Now, if their waves are a little bit bigger, you might not even see this boat until we get this close, right? And so these waves are hiding the boat. The waves in the foreground are hiding the boat. Okay. Let me, I got another one.
That
So-
was one of the big things that clicked for me. Once when I saw these kind of videos, I was like,
this is the one that got me. I went out and bought a
Okay.
P900 tripod, went out, started zooming in on things that I shouldn't see. I was like, okay, the curvature calculator is wrong. And then I'd go to the debunking sites and I'd listen to their stupid answers. I'm like, okay, I'll use their formula, which is half the amount of curvature. Still, I'm seeing things that I shouldn't be able to see, right? Here's the one, you know, people argue, well, that boat's not far enough away, blah, 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 blah. Well, using globe math, this camera is 1 foot off the water, 9.4 miles away. There should be 59 feet of curvature at 9.4 miles. That's according to globe math, not flat earth math, globe math. Not only can we see the entire thing, we can see the surface of the water for dozens of miles behind it. Because remember, once it goes over the curve, you can't see the surface of the water beyond this physical curve, right? We can see the water far, far beyond. We've done laser experiments, sonar experiments, microwave experiments, just zooming in with camera. There's tons and tons and tons of experiments that have shown, that things go away. Look, this is sticking up pretty high above the horizon, right? So why don't we see what's going to happen to this? Are we just going to lose the land? Well, that land's pretty high too. Wait a minute. What's going on here? And it's gone. It's gone because you can't see it because its angular size got too small, right? What do I mean by angular size? I can see 180 degrees almost, right? And so that's 180 degrees of size. But if I was holding a 2x4 right here, there's 180 degrees. As I move it away, it gets smaller and smaller and smaller. Its angular size gets smaller and smaller and smaller. Once something gets below 0.02 degrees, your eye can't resolve it. But a super zoom camera can zoom in and increase the angular size. You with me? You understand that? So here's what I call the wavefront edge. I got to pull up the video on this. So this is a wave right here. This boat is in the middle of a swell, and the whole lower deck is hidden.
Yeah.
When I zoom out on this boat, you can't see any of the water that's beyond this boat, and you can only see the boat from here up. And you would swear that it's over the curve of the ocean if you didn't know any better.
Yeah. Are there any more videos like that of a ship or anything that's going beyond the horizon?
So I'm going to show you where to find all of that stuff. But here's one that I like. This is so we have this wavefront edge here, but there's something going on. You can't see, as it's kind of fast, but you can't see behind this. This boat is going out into the mirage, and you can see it's miraging below it. So if that boat wasn't there, you would see the horizon right where this hard line meets this nondescript water. Let me jump far forward here. This boat, you would think the horizon's here, especially if there was no land there. Okay. Yeah. You would think that this is the horizon because it would be reflecting the sky. But look, this boat is still on the water. It's not floating.
Yeah.
Okay. And here's an example of angular resolution. There's no matchbook here, but as I zoom in, right there's the matchbook. Okay. And as I zoom out, it gets miraged, its angular size becomes too small, and now you can't see it. Now, if I stood up taller, there it is.
Oh, yeah.
You can see it right there. All right.
Mm-hmm.
But as I go down, this is how we see the world across the plane. You can now see it again. Now, other people will say, well, here's a row of hotels. I believe this is off of Florida, somewhere in Florida. Maybe not, maybe somewhere, it doesn't matter. And we're clearly missing the bottom of the building. Two things are going on here. We've got some waves, closer waves are hiding part of the building, just like my finger. Can my finger hide my whole face if my face was a building? No, unless that finger was closer. Right?
Right.
These balconies are all the same height. Same height. What's happening? They're getting compressed. Look how thin this last one is. So there's atmospheric compression. There's literally the last few feet or yards of atmosphere on top of the water is the thickest. It's the most distortive. Is that a word?
I don't think so.
Not. I'm making it up. Okay.
Yeah.
Now a word.
That's another thing as well. If it was a globe, the buildings wouldn't be like that. They would
argue that
like
it's such a little difference that you wouldn't notice it. They want their cake and eat it too. But here's the thing. Atmospheric compression, wavefront edge, end of story. Okay. And now when I zoom out on this building, this whole building disappears because your eye can't see it. It's too small. It's only because our Nikon has gave us flat earth cameras that prove the flat earth. They don't know it. They're the downfall of the globe. So globalists, if you're looking for someone to blame Nikon. Okay.
So someone contacted their customer service and asked them how far they'd be able to zoom in, and it was something like 120 miles with clarity.
Right.
So with the people using P900s, P1000s zooming in on the moon, does that mean that the moon is only that distance? Because the way I think of it is, you look at the moon, it has a certain size. I was going to research its actual size. I don't know if you know this, but imagine whatever piece of land on Earth is the moon. Would you be able to see that piece of land at 232?
Right. I've done that with the big crater on the bottom of the moon, the one that's the biggest one that you can see with your naked eye. It's supposedly 40 miles across. So we've gone on Google Earth, found something, put a circle 40 miles in circumference or diameter, whatever it is, and we zoomed out and it disappeared. It disappeared just at like a small number of miles. Okay. It just disappeared.
Exactly.
Right. Yeah. As far as Google Earth will let you go. And so you believe that we can see that on the moon 250,000 miles away? People don't do the math. That's the problem. Because it actually makes your brain work.
I heard this thing about how Aristotle noted that, there are stars there are stars seen in Egypt and Cyprus, which are not seen in the Northern Hemisphere. But, this phenomenon can only be explained if humans were viewing it from a round surface, right? How would you explain
Wrong.
that?
Wrong.
No?
I've never heard that question before. Damn it. Earth is a globe. Okay. So this is just showing you a time lapse over Skunk Bay. No tide here. The beach disappears. The buildings disappear. Atmospheric distortion hides things sometimes, not all of the time. Okay. It's just a thing. Okay. And this is a time lapse over the Suez Canal, 100 miles long. There should be over 100 miles, a mile of curvature, right?
It's 1,000 miles. It's 1,000 miles.
It's
100 miles. Sorry,
it's 100 miles. So it's 6,600 feet of curvature, over a mile of curvature. No curvature. It's just flat. Okay. So let's talk about
the Nile. I was thinking.
Yeah, well, that's a good one.
That's like what's that? 4,000 miles, and there's only like 1 foot of difference.
Right. There's right. I mean, I could argue on the globe side for that, but it's such a ridiculous argument. So, sun perspective going down. Okay, so if I was over here, I would see the line going the opposite way. I would see it. This would be the high star, and this would be the low star. Right, the low sun. Right. If I was right underneath where the sun is on the flat Earth plane. You with me?
Mm-hmm.
I would see it the other way due to perspective. Right. If you were having a side view of that, you would see us, the sun going straight across and both of us standing under either end. Right. We'd be like this. The sun would go, but this guy sees it going like that. And this guy sees it going like that. Right. So here it is. So you and I are in a room together. 10-foot high ceilings, big empty room. It's it's got random lights in the ceiling. And we both look up and look, that makes a heart, that makes a bull, and we're drawing pictures, right? Now we expand the room to 10 miles wide. And I send you 5 miles down the way. Have you ever been, where do you live? What state? What country? Where are you?
I'm in the UK.
You're in the UK. So do you have any giant hotels like we have in Vegas, Las Vegas? These hotels are so big. On the Bellagio, if you go to one end of the hallway, they have lights in the ceiling. The lights at the other end of the hallway look like they're touching the rug.
Right.
Imagine if that's only a hallway. I don't know. Is it a 1/10 of a mile? Right. I just sent you 5 miles away. Not only is the ceiling going to merge with the floor, I'm no longer going to be able to see you. Call you up on your cell phone, and I'd say, look up. Tiana, look up. What, do you see that heart and that bull? No, I see a dog and a sword, right? I see different, and I'm like, I don't see those.
That's true. Yeah, that makes sense.
Right. Here's the thing. If the Earth is a ball, you got the North Pole and the South Pole, and Polaris is directly above the North Pole, our North Star, nobody below the equator would be able to see it. If I'm on the equator here, I'd be able to see it right on the horizon. But anyone below here, it's now below the curve. Polaris has been seen as far as 30 degrees south.
Oh, wow.
It just gets harder and harder because as things go down to the horizon, they merge more and more and more, and it just becomes, it's just an opaque barrier you can't see through. So that's why people in the outer south can't see the sun or the stars at the same time in the inner north.
So everything really essentially is like an optical illusion that we can't see.
Like government?
So what about time zones then? I guess you can explain time zones through the way you explain how the sun moves.
Damn it. Earth is a globe.
But I think that is sort of answered through the way the sun moves, how you explain that phenomenon, right?
Yeah. So here's our time zones. So let me turn on the time zones. Where the hell are they? They're right there. Nope, that's the zodiac. All right, here's the time zones. So, all right, so here, whoops, I hit it twice. So here are the time zones. Wherever the sun is, it's noon. So it's about to be noon in Sydney, Australia. I called my friend PK up. I'm like, PK, where's the sun? He goes, it's right above me. It's noon. And I'm over here in Africa. It's midnight. Here are the times. Here are the time zones. As I showed you, the sun takes its light with it. It goes away.
Yeah.
It merges into the horizon. Its light does not travel that far. Even when it wasn't below the horizon, at a point, it can no longer send its light. You're brainwashed, not you, everyone, that light travels for billions and billions of years. Those stars we're seeing could be gone a billion years ago. It's the light is finally getting to us. Does that make any sense to you? Right? As light expands outwards, it gets thinner and thinner and thinner and weaker and weaker and weaker. It's like blowing up a balloon. The balloon rubber is the light. The bigger it gets, the more area it has to fill, and the thinner it's going to get to the point where there's no balloon left.
Right. Yeah, that makes sense.
Okay. And so the wavelength, it's like sound. If you and I were 5 feet from each other, no problem. I send you a mile away. I'm like, hey, you don't hear me because the sound spreads out. Same thing with light. Just goes a little farther, a little faster. If it's traveling at all, it might be instantaneous. I don't know. But it spreads out over distance, and that's testably, measurably, provably, scientifically provable. So here are your time zones, right? So let's just, while we're here, we'll show you seasons. So right now, the sun is, see the outer yellow line is the Tropic of Capricorn. The inner yellow line is the Tropic of Cancer. On June 21st, the sun is over the Tropic of Cancer. So let me 1, 2, 3, 4, 5, 6, 7. April, May, June. So in June, the sun is already here. And look what it's doing. It's coming right over the UK. Pretty close. Never over the UK. It's my summer here. I'm right here in North America on the East Coast. And so the sun is close. What happens when a light in the sky gets close to you? It gets higher in the sky. Now that the sun is on its way out, so in December, it's going to be out here. What happens when a light goes farther away? It goes lower in the sky. So every day when you go out and look at the sun at noon, it's lower in the sky. Why is that? Is it because we're tilted, spinning and twirling and whirling? Or is it just because it's moving farther out?
And I think the deserts are the perfect example of where the sun goes over the Tropic of Cancer. It goes over the Sahara, the Mongolian desert, the Mojave desert.
And so where we are, the sun comes close to us once, and then it turns away, goes away. People in the outer south, the sun comes close to them, and then it goes away. But people in between the tropics, the sun will pass over them twice a year. Right? It'll pass over them once on the way out, once on the way in. That way the sun never gets too far away. The thermal heat of the earth always stays warm. That's why it's always so beautiful and warm in between the tropics. So in December, it's the height of summer in Australia. Why? Because the sun is directly over it. It's hotter in Australia than it is in the UK because the sun is directly over them.
Okay.
This is an experiment you can do. In the height of winter on a freezing cold day, go outside at noon where the sun might be 50 degrees off the horizon in angle and look at it and see if you can, how warm it feels. See if you can take your gloves off for a little while. It gets cold where you are, right? The freeze?
Yeah.
The water freeze where you are?
Sometimes it's
rarely, but
okay. Well, here, when you breathe in through your nose, your snot freezes. Okay, it's that cold, right? And so, looking at the sun in the winter, I can't feel the heat on my face. Do you know in the heliocentric model, they tell us the sun is 3.5 million miles closer to Earth than it is during our summer, right?
What?
So I'm looking at it. Yeah, upside down world. So I'm looking at the sun at the high point for the day in December. I could feel the heat. I could barely feel the heat on my face. It's freezing outside. But in June, when the sun is 3.5 million miles farther away, at sunrise, where the sun is literally at the farthest tilt it could possibly be from my position, and they tell us that this tilt causes the season, I'm tilted all the way away at sunrise. I can feel the heat immediately and warm. I get hot. That's because it's close.
This really is like
Season.
Occam's razor, isn't it? Like the simplest explanation really sounds like the right one. They make it so complicated.
Exactly.
I don't actually ever understand anything that globethists say.
So you don't use your common sense. And
But maybe because
sounds-
I always, fault that on my lack of understanding of astronomy and just astrophysics in general, because they can very easily outwit you when you don't know enough.
Well, they want to say, you don't have a degree, where did you get your degree? Well, the people that have the degrees are the most indoctrinated. I took 4 years of astronomy. I was awesome at it. Okay.
Oh,
I was
really?
amazing at it. Yeah, horrible. It's all nonsense. It's all lies. It's all made up stuff. But I was good at figuring out the math. And look, that light that they tell me is Saturn. That's 30
Did you
million
have a
miles away.
telescope?
I had an observatory for 4 years at my disposal, like a rooftop
Wow.
observatory. We were in there 3-4 nights a week. Okay.
Oh my God. So
Well,
wait, so your mission wasn't always proving flat Earth?
Absolutely not. I mocked people that said the earth was flat. I banned them from our social media for even
my God.
suggesting that I look at the stupid topic. Right. But then I was forced to look and actually use my own mind. Right. So the big question, which we should get to before we run out of time, is why? Why the lie?
Yeah, why the lie? Other than the fact that it makes us believe, it denies the fact that, something created us or that there is a God, perhaps.
That's a good one.
Other than that,
I used to-
also, Dave, what about the fact that there are other space agencies, right? And NASA's not the only one. How come they're all in such unilateral unison? Why is there such a general consensus over the shape of the Earth? Is there a lot of polarity in the scientific community with this, other than just flat earthers?
So all of these other space agencies, they all are part of it. They all work together. What do you mean all these countries working together? Well, I can name 2 things that they all work together on. They all sign. It's filled with resources. There's no animals or people or plants to disturb. But they all agree it's been in place since 1959, and you can't even question it until the year 2041. But they all agree. The other thing they all agree on is that we all need this, that we all have to do this, okay, to ourselves, right? All in lockstep, all of them at the same time. Yeah, they work together, okay? Yeah, they work together. The Cold War, America, Russia, nonsense. How many people died? 0. How many battles were there? 0. It's all just a big building up of what they call the military industrial complex, okay? So what if the world was set up like this? Here we are, here's our pond, here's Antarctica, and there's other ponds. Other ponds just thousands of miles away instead of light years away. What if we lived here? This is Antarctica. Now this right here, I don't know, look at America. America is like 3,500 miles wide. This is like 3,000 miles, okay? Maybe it's even wider, who knows?
Yeah.
And then what's out here? More land. What's another word for more?
Excess. I don't know.
Extra.
Extra.
What's another word for land?
Earth.
Territory. Terra. Extra terra.
Oh yeah.
If somebody lived out here and they came to visit us in here, what might we call them?
Extraterrestrials.
From where?
Space.
The outer space.
Outer space, right?
Right there, right in front of you.
Such a play on words as well. Wow.
But what if it was set up like this? Right? And there's another sun out here, another sun here, and another sun in here. Well, you'd never see them. And there's been some interesting videos of Antarctica where like another sun showed up. So maybe at a certain time, this sun passing by, maybe that's why they don't want us to go to Antarctica, because we'll see the other sun circling because we're close enough to see it. Okay.
So
I got to try to find those videos that showed like another sun. right? And just
One
one more.
last question before we wrap this up. I mean, I know that it's quite unclear
We're
whether
not done yet. We're
Okay.
not done yet. We got 5 more
Okay.
minutes. Go ahead.
So I was just going to ask about, I don't know if there's a lot of consensus among flat Earth believers that whether other planets are either flat or spherical, because I think most flat earthers I've spoken to over it at best don't really have a specific stance on the topic. But what are your thoughts on the shape of the other planets?
What planets?
So wait, so what do we see through a telescope then?
Well, this is what NASA shows us, clearly a cartoon, right? We're seeing lights in the sky, right? We're seeing lights in the sky. Hold on.
Yeah, show us the stars, what they actually look like.
Right. So
No way. What do you mean what planets?
hold
There's
on.
No other
Yeah.
planets?
Well, so all right. I'm going in too many different directions at once. I'll answer the planets thing in a second.
Okay.
So in NASA, they show us, well, these other planets were discovered. Here's 6 new planets that they discovered. So let me ask a question. Are these 6 planets that NASA discovered? Or are they the bottoms of frying pans? Okay.
It's hard to tell, actually.
Right. What planet is this? What
Mars?
planet is that?
I'm not
Mars?
good at this. No,
Come
I
on.
don't know.
Is that Jupiter?
Jupiter, right.
Is it Jupiter?
Is it? I don't know.
Or is it a meadow with ducks in it?
Oh my goodness.
Okay. Right? This is
It's not-
NASA. They literally made this model and painted it. And then they make you think that this is the same picture that they use all the time. Right? This is a model. This is done. This is a NASA artist. Right? And then
How
they
did
show
they let
us
these pictures leak? Or who leaked
they do it
these
on
pictures?
purpose. So this was supposedly some craft, heading towards Jupiter, right? So we got the dark storm or the red storm spinning. You got these clouds going this way, you got clouds going that way, right? So you have all of these moving gaseous planet, right? But then they show us, this is the picture from 2014 that everyone loves. And in 2016, they go, oh, we got a picture of the northern lights on Jupiter. Look, that proves that it has a magnetic core just like Earth. Wow. Wow. Right? Do you see this cloud here? See that cloud there? See this cloud here? See that cloud there? It's the same picture.
Why is it the same?
It's the same picture. That's why.
Oh my God.
Okay.
But they have so much funding. Why do they not cover their tracks?
Do they have that much funding? I don't think they have that much funding. They take that money from us. That goes into dark budgets. NASA, I think they get $5,000 a month. Okay.
Surely they have enough money to not doctor the same images twice.
I think they do it on purpose. I actually think they're really stupid, and I actually think that that they can't come up with anything new. That's why they repeat the same things again and again. My prediction for Artemis, when they finally put people on it, we have another Challenger event. Okay. But don't worry, no one's ever on those rockets, right? So
yeah.
How about this? Is this another Earth-like planet?
It looks like Earth.
Yeah, it does, doesn't it? But in reality, it's just a rusty old propane tank
What the hell?
with a fisheye lens. All right.
Oh my God, I feel really
So-
stupid right now.
It's because that's the problem. Why people can't accept flat Earth because they have to admit that they were really stupid. I was so stupid. I believed all this nonsense. This is Venus. Now, is this in focus? Maybe not. But what's it showing us? It's showing us that Venus is not a planet. It's an energetic light in the sky. And when you do the math and look at the sizes of these planets and stars and everything, if you believe in planets, you believe in stars. Okay. So our sun is a yoga ball and the Earth is a small marble next to that yoga ball, right? The size that they tell us. So we move the sun 93 million miles away, and I'm standing on that marble, and it's the size of a coin held at arm's length, right? The sun is about the size of a coin, right? If I doubled the distance, it gets smaller, right? It went from filling, if I was right next to it, it'd fill the whole sky. Now it's the size of a coin. Double the distance, it gets smaller. If I doubled that distance, now it's 4 times as far away. It's a lot smaller. Could you see it? If I doubled it, now 8 times farther away. That's a light hour. 8 times the distance is 1 light hour. The distance light travels in an hour, supposedly. It's scientifically provable that you couldn't see it, but let's just be safe. Let's make it 24 times farther than that, a light day away. 24 times away. There's no question. No one could even argue that you couldn't see the sun. 24 light hours away, a light day away. They tell us Polaris, our North Star, we can see with our naked eye, is 48 times bigger than our sun. So if I made it 48 times farther than a light day, that's 48 light days away, right? 48 light days away, you couldn't see Polaris. How far do they tell us Polaris is? I'll give you A, B, or C. 48 light days away, 50 light days away, or 430 light years away.
C, I'm going to go with C.
Good answer. Okay. But you may be wrong in the future because they're talking about it might be 100 light years closer than they've always told us it was. Right. So they're just pulling things out of their rear ends. Okay.
Yeah.
So
and the stars used to be called one. The planets used to be called wandering stars.
Really?
Yeah.
Right. And so when we look at Pluto, this is a picture, I forget what Voyager or whatever took a picture traveling at 60,000 miles an hour in deep space, got this high res picture that has a desert or whatever that looks a little bit like the dog Pluto. Maybe that's just my imagination, but it looks like the friggin' dog Pluto from Disney. Okay.
It does.
And didn't that happen in the same year in the 30s as well?
And here is, I think this is one of the moons of Mercury. Has, I don't know, that's just a coincidence, right? Right. And then they recently got this picture of Saturn. We got the Northern Lights again, proves it has a core. Look at this. Look at this.
That is hilarious.
Right?
Professional Photoshop.
You see the latest picture of some new planet?
So what happened with Pluto? The fact that they said,
and you can even see the moon on this planet. Let me see if I can zoom in on that. Oh, and I'm sorry, it's a rotting orange. Okay. Okay.
Wow. That is intense. And it's really interesting because my mother actually sent me this video, and and I'll actually link it down below because it's this former NASA and what do they call the Lockheed Martin, right? The Lockheed Martin, she's was an employee there, who said she was told by some of the engineers that she worked with that the Earth was flat. And
yes, there's been many stories. There was a NASA whistleblower out just recently that his father was security when they faked the moon landings. I had a guy that was emailing me back and forth. He was moving out of the country and then he disappeared just when it got interesting, really, really interesting. And the Earth is demonstrably, provably flat. This is what NASA shows us. This is what real life telescopes show us. Okay.
There's been a Polish astronaut who said that the Earth is flat. He wasn't expecting the question. You can find it on YouTube, and also a Russian cosmonaut.
Right. This is the star Sirius. Does that look like a burning ball hundreds of trillions of miles away? Remember how big a trillion is, right? Or does that look like some energetic, sentient, if you will, part of this living system that we're in? Okay.
Underwater.
Yeah.
Wow. So what do we think is above and below?
Well, again, anything above as high as we can actually get or beyond the shoreline of Antarctica is speculation, but there's lots of evidence that'll show us. There's a lot of people believe that space is water. A lot of the rocket launches that we see, it looks like they're skimming along water, trying to break through. And NASA, with all of their terminology, the Sea of Tranquility, docking ships, they're all nautical terms, everything that they do in space. These are other stars. Okay. Here's one. This one you can see with your naked eye. It's the star Capella. Look up where it is in the sky. Look, it looks just like this. Wow. What is this? Is this a burning ball? Right? And then this one is Arcturus. another fascinating one, right? It looks like that when you're looking at it in the sky, but then you zoom in on it. How am I able to zoom in with my P900, P1000, 125 times zoom if this thing is trillions and trillions and trillions of miles
True.
away? I can zoom in on this, but New York City, which is 25 miles away, I zoom in and I can barely get any detail.
Oh
I
my
can
God,
zoom in on
yeah.
the moon and I can get incredible detail. I zoom in on the World Trade Tower now, and it's like, which one's closer? The moon or New York City from Connecticut?
Wow. I've
I was
never
going to
thought of
ask
these
you about
questions
that.
actually.
With you actually saw the New York event happen in
I
real
did.
time. Yeah.
And not on TV. I
Yeah,
saw
yeah,
it
in
with
real
my own
life, yeah.
eye, in real life.
Yeah. So
And-
have you ever measured the distance from where it is to where
Yes,
you were
25
standing?
miles. 25 miles.
Okay. Yeah. So yeah.
Or maybe it was like
So you wouldn't have
where
been
I
able
was
to
right
see
there. It
it.
might have been like 22 miles. No, I saw the whole freaking thing. And we
Yeah.
call that day 9/11 clear. Okay. Because it was so clear. I've never seen a clearer day ever than when that happened. And that's a whole nother podcast.
Wow.
So going back just real quick, I'm going to give you some information. So just going back, this is now, I'm not claiming this is real. I like it. It's scientifically possible. Versus the closest star is 4.5 light years away. That's what they tell us. 25 trillion miles.
Hmm.
Okay. So if you're going a mile per second for 31,000 years, you'd only be 1/24th of the way there. Right? Let that sink in. If you're going 100,000 miles an hour, which is unfathomable, it would take you 28,000 years to get there. So the idea that aliens coming from our closest neighbor, where the other ones are magnitudes farther, coming here and crashing in New Mexico or whatever, is ridiculous. It's scientifically impossible. What if we lived here? What if we lived right here? Right? In this pond. And we're trapped here by the powers that be, having us believing that we're living on a ball, and all of these other pieces of the plane, puddles on the plane. What do you call a piece of a plane? A planet. A planet. It's a piece of the plane. What if these were all of the other worlds right here, just thousands of miles away? Maybe from here to here, maybe that's 10,000, 20, 30,000 miles. Who knows? 50,000 miles. It's still close compared to light years, light minutes. None of this isn't even a light minute across. Okay.
Yeah.
This is scientifically possible. We're trapped here by the powers that be that don't want us to explore. There was airships and stuff that travel all around the world, but they demonized them with the Hindenburg, hydrogen's too dangerous. And then NASA controls all the helium in the world. NASA controls all of the helium in the world.
What does that mean?
NASA owns all of the major helium companies in the world. So if you wanted to start a dirigible inflated company, you wouldn't be able to get the helium.
How clever. Wow.
Yeah. So
I've got to give it, they are actually really clever.
This is my app. It's the Flat Earth Sun, Moon, and Zodiac Clock app. It's available for your iPhone or your Android. What do you have? Android?
iPhone. That's
You have an
amazing
iPhone.
that you have an app.
Wow. And that's because if you Google Flat Earth, you get nonsense. You get a bunch of stuff that they want you to see. The ones that control the world. Okay. But every day, this is what I tell people. Just get the app. It's $3 and just watch the daily video each day. Each day there's a new video that shows up here. Watch it. And after 2 weeks, if you can come up with one globe proof, send it to me. You win 3 Bitcoins. But before you do, you have to hit the question mark button. And when you do, up comes, I just loaded the app, so it's got to load for the first time. Up comes the questions that you're going to ask. Hey, Dave, what about eclipses? What about ships over the horizon? You asked me about more ships over the horizon. Click that button. And up comes videos that YouTube won't serve you. These are all hidden. These are all hidden videos. But the first one right here, 10-minute video, watch that. It'll explain everything. This is the best video showing you what we're seeing as a ship goes away. This woman filmed the ship going away and is showing you drawn lines, showing you exactly what's happening. And then once you see that, then you can start to see. And so there's that. Then this is more resources, like our interview. When you post it, will be right here under interviews. So all my interviews are here. There's in this playlist alone, there's over 600, I think. These are some great TikTok channels, other stuff, Globebusters 24/7, biblical flat earth stuff, all sorts of stuff that'll keep you busy for years. Okay.
Dave, just a quick question on that. The TikTok guy, Dare to Know.
Adults books, right? One of my favorites is The Iron Republic. Great book about people that moved out of here in the 1600s beyond the ice wall. There's an advanced civilization there, and an explorer, an actual congressman or a politician from New York in the late 1800s left here. He was disgusted, and he found his way through an opening in Antarctica and lived there for years, and then came back and told the story of this advanced civilization. All sorts of fun stuff, flat earth products and stuff.
How long did it take you to develop this?
It's never ending. It's never ending. This is homeschool stuff. This is homeschool curriculum right here. All sorts of stuff to educate yourself and your children. And then the biggest thing on here now is here's the thing. Are you married or relationship?
Nope.
Here's the thing. Once this digests, you no longer can date globies. I'm sorry. Okay. But the good news is there are tons of people, tons. So let's just zoom in. This is just my area here. Let it load. These are
my God, that is a lot of people.
You can click on somebody and you can send them a message. You can look at their profile, see if they're single, see if they're interested in work. This is a
flat earth / dating app.
It's a dating app, job app, friends app, because here's the thing. So people that are awake to flat earth, we all have a lot of the same understandings of the world, that, the nonsense that's going on is nonsense, that we don't live on a globe. And all of these people, male or female, they're all super attractive because their minds work. They're amazing people. Okay. And so let's, if I click this little button right here.
Probably all unvaccinated as well, right? So there's that.
I would say 99.99% of them. And the only ones that did it because of some life circumstance that made them do it. You're in the UK? Is that where are you? You said you're in the UK?
Yep.
Plenty of people around you. Plenty. This is the UK. Right?
It looks like everyone, doesn't it?
There's a lot of people everywhere. And
why is it like more people in certain areas?
Well, it's because those are people these are populated areas.
Oh, okay.
When you look at the populations, it works there. And then also because I speak English and I'm speaking to English speaking places, but it's growing. I mean, look, we're in South Africa. It's growing. I did some radio shows there, and this is spreading, and people are spreading it. On the app, there's a fun thing. This shows you your status, and if you click it, so these are the different levels. These are the number of people that I've referred. So I just have I think I'm a crab, whatever. Yeah, I'm the crab. I have 28. Let's say 28. And as you gain points, your icon, your dot will change so people can appreciate how well you're doing. And then there's to send messages to people, to use the weather app, to use I have a thing that pings you every time somebody downloads the app, which is kind of fun. You're like, yes, another globie dies. Okay. I don't mean dies, it means is reborn as a flat earther. Those are premium features. You have to pay a subscription. The subscription, ready for this? It's $11 a year. Okay. $11 a year. If you ever bought anybody a drink in a bar.
No, I think it should be worth way more. That's mad.
It's $11. And guess what? I have a new thing. I have a new messaging system coming up that's going to be amazing. Coming up any day now, actually.
Bring it on.
If like a lot of people like, yeah, I'm on my parents' account, I can't do the subscription. You can use referral points. 11 referral points buys you a year subscription. So if you have 11 referrals, Boom, cash them in. You got a year subscription. Okay.
£11. Wow.
11. That's it. Nothing. You're like, I'm not spending that 11 pounds.
Are
Hey,
you
who
not going to
wants
put
a
the price
shot?
up as time goes by?
You know what? Everyone's keep telling me to put the price up. I don't want to put the price up. I want to put the price down. And if I give enough people, I can even like I made it, doing the referral thing that doesn't pay for the app. The app costs a ton of money, right?
Yeah.
And it costs a lot of money. It's almost 5 figures a month now. It actually probably is 5 figures a month now. Okay. But that's okay because we're there already. We're there. We just need people to keep referring. But here's the thing. It's not about the app. It's about getting through Google censorship. And this app is, it skips Google censorship. Like when you watch the daily video, the next one that auto plays isn't a Google pick. It's my pick. Okay.
Okay.
Right. And when you hit these other buttons, if you go into the images button, lots of great memes. A lot of people, let's say you're out in a noisy place and you're trying to talk flat earth. You show them some memes, you're like, look, the outer lands right here. Or you can flip between all these different things. And there's I got some users that have made some awesome memes. And you just flip through the memes. The memes will wake up. Look, memes. This is a meme. You were taught this in school, this meme. There's no proof. You ask about what's below the earth. No one's ever gotten below 7.5 miles, whether the earth is flat or a globe. So flat earthers say, we don't know what's below 7.5 miles. Globers say, oh, this is, we know we during that 7.5 mile dig, we were wrong every step of the way, predicting what we were going to hit. Then we hit an impenetrable barrier. And now we know what the next 4,000 miles is. Okay. This is nonsense. This is a meme that you were brought up on. But this is a great way to show people what's going on. And the other thing is, if you're competitive, if you hit the little Ward Cup, this is the leaderboard on people that have done referrals, the top 100 people that have done referrals. So this is just something new. So there's not a lot of big numbers on here yet. But our big guy right now is Caleb, who's got 718 referrals. This is fake. I was just testing the app with Zach today. I needed to find him, so I gave him 500. He'll be going back down to 4 when I'm done with this.
So, Dave, if you were so interested in astronomy, why didn't you just get a degree in astronomy so that you can actually?
Well, I was like, what am I going to do with astronomy? Like, what am I going to do? And be, but when I realized,
for the sake of all the people that debate you and say, oh my God, you're not even credible enough to speak on this,
because it's like, get a degree in baloney. It's pure and total nonsense. I don't need a degree. For people that want to debate scientifically, we got Austin Whitsitt. He's one of our guys. Okay. And he knows the science so well. He's so much better than me at it. And so talk to him, right? I'm here. This is Flat Earth 101. We did 101 plus a little bit with you today. This is the beginner basic levels. I bring people in like, look, this is it. Now that you got it, now you can start watching. Watch Globebusters on, it's on every Sunday, 3 p.m. Eastern here, or you can just watch it whenever. Globebusters. It's a great show, and they go over, just you can learn from that. Learn from the app. Go to, just watch the daily video. The daily video alone. And if you don't want to wait, click the archive button, and you get all of the years divided by months, divided by videos. All of them, all the way back from the beginning. The best flat Earth information ever. It's right here. Amazing. And one thing I'm going to announce on this show, first time ever. It's almost finished. The planning. We're doing a True Earth Mount Meru virtual summit on November 11th, and anyone around the world can sign up. You join, watch it live, ask questions, and we have a whole bunch of presenters. Some I'll wait for the list to come out, but we got some great presenters, and it's not all flat Earth. It's all true Earth and truth. It's going to be an amazing summit. So keep an eye out for that. And you'll actually, on the app, if you hit the little shopping cart button, here are, this is my t-shirt shop and all sorts of fun stuff. But right here we have Flattoberfest right? Which is anyone in the US. It's coming up October 20, 21, and 22 in South Carolina. That's going to be a great conference, but as soon as we announce the conference, it'll be right here next to that. All right. So that'll be November 11th, 2-day conference, virtual. So you can watch it from your phone, wherever you are. You can watch it from your TV. You can watch it from your computer. And if you join the conference, you can even watch it if you missed it. You can watch it. You can watch the replay.
That's amazing. Well, this has been quite the insightful conversation, Dave. And when it comes to when it comes down to it, like all that anyone really knows is what they're taught, unless we really just take 10 minutes to actually question every fundamental tenet of our belief system. But I remember asking a lot of questions in school, but I think the teachers took quite an instant dislike to me as a student because I was so inquisitive. But I genuinely think that, belief, a lot of people believe things, right? And I think belief really is like the enemy of knowing. And so
belief is, that's a Crow 777 statement there. Belief is the enemy of knowing, and that is the absolute truth. Question: where do I live?
Where do you live?
Yeah.
Where do you live?
Where do I live? What country do I live in?
America.
Okay, and then where in America do I live? I said it during the show.
I don't remember.
I said on the East Coast.
Okay.
I live near 25 miles from New York City.
Yeah.
Right. So let me ask a question. That would put me in Connecticut, just in case you don't know the geography over here.
Yeah.
And the question is, do you believe I live in Connecticut, or do you know I live in Connecticut?
I know.
Or do you not believe it? You know I live in Connecticut. How do you know?
Not yet, but if I wanted to
You
know,
believe
I
it.
think you could verify it.
Yes, you could verify. You can go online, find me, go on Facebook. Oh, there, find his friends. Look, they all went here. They seem to be in the same town. Oh, I found his high school. Bam, and you know that I live in Connecticut.
Right.
Okay, that takes time and effort. Okay, and a lot of people are unwilling to put in that time of effort because they want to watch their sports game, they want to watch their movie, and they want to drink their beer, and they want to smoke their weed, and they want to, they want to do all of this other stuff rather than. But here's the other thing: you can't confirm everything. You have to look at somebody in their eyes, see their micro expressions, and go, "Is that person telling me a truth, or is that something I need to go check?" Of course, you're not going to double check. Yes, I live in Connecticut.
Yeah.
Right? Why would I lie about that? But it's still a belief until you confirm it. Okay. Yeah. But we have to operate on beliefs, right? We have to live. But if there's something big like outer space, planets, we're living on a spinning ball, you're going to die from the boogeyman. You need to do your own research.
Yeah, because the truth should always stand the test of any inquisitive thought.
Always. Right. And when you mention flat earth to somebody and they get triggered, why are they being so triggered? Right? If it triggers you, why are you being so triggered? If you have the truth that you live on a spinning ball flying in an infinite space vacuum without a barrier, this nonsense.
Dave, I saw a little bit of that interview that you did with Professor Dave. I think it was a panel with 3 people.
Right.
I couldn't watch a lot of it because I just couldn't stand how just unbelievably uncouth the man is, the way he speaks, and just resorting to such petty name calling. I just couldn't really.
So here's something for everyone that has the app, and you can also find it on my channel. But if you hit the web button and you go down to debunking the debunkers right here with that ugly mug right there, if you click that, the first video, actually now the second video, is Flat Earth Dave humiliates Professor Dave.
Yeah, I think that's the one AD sent me today because I was telling him I was
so good. It's so good. This guy, Mind Shock channel, he is a genius when it comes to fallacies, logical fallacies. And he kept a score counter. I'll give you a spoiler alert. I think Dave got like 290 and I got 15 just because I was saying don't be a dick.
Wow. And it probably doesn't have that many views, right?
No, it's actually getting up there. But it's not unlike the Professor Dave stuff. Google pushes him to the top. Okay. Google pushes him. Like when you search Flat Earth, it's one of the top videos that shows up, his video. But here's the thing. You watch that, you had a strong enough mind to go, this guy is acting like a total tool. Other people will be like, oh, I don't want to feel like an idiot. I'm going to go with the mocking scientist, who's not even a scientist. Okay. He's a dropout, musician dropout who.
I didn't know that.
Oh yeah, absolutely. there's actually a few videos that show him admitting that he didn't finish school, him admitting that he was a substitute teacher and then the teacher quit and they're like, oh, just go teach the class, you know? And so that's how he became, I don't even want to talk about him anymore. He's
It's
just
also quite telling. You only get that angry if you're actually being challenged.
right. And he didn't understand the simplest concepts. So anybody that thinks that I was humiliated by Professor Dave, watch that video and then you can send me an apology.
I'll link it down below, actually.
Yeah,
That's
it's a good one. Yeah.
Okay.
Thanks.
Well,
And
that was wonderful. Thank you, Dave. And if I have any more questions, I'm definitely going to have you on again, because I'm sure once I get the app and start delving into it, I'll come up with some more questions.
All my channels, my YouTube, which is nice short videos. If you're new, DITRH. I have my Flat Earth Dave's interview channel. I have my Flat Earth Clock app channel, which has like a wide variety of stuff on it. But everything can be found at flatearthdave.com. My TikTok, follow me on TikTok, right?
Is there a way I can personally contact you?
Yes.
Okay.
You have a confirmation email from me. That's my email.
Okay. Okay. Brilliant.
Okay.
All right.
Wait, did you make the booking?
I think it was AD, but I'm sure I got an email as well.
Can you still hear me?
Yeah.
Yeah.
Yeah. Okay. Yeah. That's. I wasn't sure if I had a bit of a problem on my laptop.
There's a book.
Yeah,
If you have a show, there's a book, Flat Earth Dave link on the website. So anybody that knows the show, I don't mind talking to flat earthers. It's fun, but I want to talk. I want to get outside of from preaching to the choir. I want to reach people like yourself or people that actually think flat earth is the dumbest thing they've ever heard. Right? Because that was me. And now I'm friggin' Flat Earth Dave.
Yeah, it's not fun talking to the already converted, is it?
No, it's fun talking to everybody, but we need to get outside. We need, now that there's 75,000 people on the Friend Finder, what if everybody woke up one person a week? This would be over before the year's over.
Can I just say one thing that I've been doing on taking the Omegle thing that you guys were doing with Jeranism?
Yeah.
I was, after hearing about Omegle, I'd never heard of it before. I was going on Omegle and waking people up to flat Earth, and I'd get a bit of abuse, but I'd get at least 2 or 3 good conversations out of it each time I went on it.
Wow,
that's what. Hey, you want to do
that's Omegle activism?
A quick experiment. So this is a new version of the app, and I'm testing out the new messaging system. So I'm going to pull up, and of course it's not going to work while I'm plugged in. Never mind. I had an idea.
I'll happy volunteer being a tester for that if you want.
Okay.
All right. Well, thank you so much, Dave. And I'll definitely get in contact with you soon.
Thanks.
And AD, you can send me the recording for this, and so I didn't get to record it. But
yeah,
it was wonderful speaking to you, Dave. You've given me a lot to think about. So thank you.
Thanks. And here's the thing. You have 2 choices now. You can go back to sleep and try to forget everything that I've told you, but it will haunt you for the rest of your life. Okay. Or you can start looking into it. And here's the thing. We have lives, we have jobs, we have all the stuff. Just when you get up in the morning, when you're having your breakfast, just watch the daily video. Just boom, click the daily video, and that's it. You're done for the day. And I do short ones during the week, longer ones on the weekend usually. And just watch that and go, oh, that was interesting. And then, during your lunch break, you'll be like, let me watch another one. Let me watch another one. Let me watch another one. And then you'll be like me. Okay.
It's quite addictive.
And me.
Brilliant. Thank you so much, you guys. Thank you, AD, for joining as well.
All right.
Our pleasure and absolute pleasure. Yeah.
Thanks.
Okay. Cheers.
All right. See you. Bye.